Hello, good day, pre-algebra. We are covering our final objective of Unit 5, CO37, going back to direct variation a little bit, okay? Actually, a lot bit, but applying it now into more real-life word problem type situations rather than just function tables, okay? But we're going to start by going back to CO36 by filling in some blanks here. The first one, every equation with direct variation will be in the form what? Who can give us the answer to this one? Every equation that has direct variation can be written in the form what? Aiden? Slope-intercept form, but more specifically, this should be written on your notes page from 36. Yvonne? Y equals mx, okay? Which is a variation of slope-intercept form. It just doesn't have that plus b. Because like we talked about, for direct variation, it's not going to have a b value written there because it's 0. Okay, y and x are directly related there. There's nothing being added on or subtracted or whatever. Okay, the constant of variation, which is the same thing as the slope, is found by taking what? The constant of variation, also the slope, just fancy name for slope, is found by taking what? Y divided by x. Okay, y divided by x. And it's this information that we're going to use to answer questions that look like the following, okay? Brian's pay, which I'm telling you is the y variable here, varies directly with the number of hours he works, x, right? What this phrase means right here, Brian's pay varies directly with the number of hours that he works, is that, you know, if you work more hours, you're going to make more pay, right? If you work less hours, you're going to make less pay. And the fact that it varies directly means that there's a direct relationship between hours worked and pay. Okay? If he earns $282.75 for working 39 hours, how many hours did he work to earn $195.75? Right? So for starters here, we're going to find that constant of variation. And if you're asking, well, how do I find the constant of variation? Right here. The constant of variation, or the slope, is found by taking y divided by x. And in this particular situation, y, his pay, x, the hours that he works. So we know that he earns $282.75 for working 39 hours. That's given to us. So to find that slope, that constant of variation, we're going to be taking $282.75 divided by 39. All right? The y value divided by the x. And someone with a calculator here, what is $282.75 divided by 39? I've got one. $282.75 divided by 39. Someone check my math. I got 725. Yes? 7.25? 7.25? Okay. What does that 7.25 mean? Aiden? Well, no, it's $7.25. Okay. But in the context of the question, what does that represent? Maybe that'd be a better way to ask it. What does it represent, John? No, it's $7.25. Okay, it's in units of money here. Okay, Anna? Right, it's how much he gets per hour, right? If we take the total, $282.75, and divide by the number of hours worked, that's going to give us the amount he gets per hour. That's our slope. Okay, so the equation in slope-intercept form, which goes back to y equals mx, we just found the m. Y is equal to 7.25x. Okay, or in context, his pay is equal to $7.25 per hour. Right? So, number 3, answering the actual question, how many hours did he work to earn $195.75? We're going to plug in the known y value, right? Going back to this equation here. If we're given the pay, that represents y. So 195.75 equals 725 times x. How are we going to solve this equation? What are we going to need to be doing to solve this equation? It's a one-step equation. We want to get x by itself. Be thinking back to our procedures for solving an equation. Opposite operations. Yep. Divide both sides by 725. Right? If we know the total, 195.75, and we divide that by the number, or by his hourly rate, 725 per hour, that's going to give us the number of hours worked to get that total amount, which is 27. Okay? So, to recap this, because the rest of the ones on this page don't have these prompts here that this first one does. Okay? But what we did first was we found that constant of variation, that slope, by taking y divided by x. That was our first step. And we knew we could do that because of this phrase, Brian's pay varies directly with. Right? That varies directly with tells us we can use this y divided by x to find the slope, which was 725. We then wrote the equation with that m value, that slope, plugged in, y equals 7.25x, and then plugged in what we knew, the total for y, 195.75, to solve for x. Okay? That was our process. It started, with that y divided by x. Okay? So when we go down to the next one here, where it says, the profit Mary earns varies directly with the number of her books that sell. If Mary earns $601.65 for selling 63 books, how much will she earn for selling 59 books? How do we know that we can use our y divided by x to find the slope and use that equation? What phrase in here tells us that direct variation exists?
It says varies directly.
Right, varies directly. Okay, that's a key phrase there. How do we know what value is y and what value is x? We have the total money earned, and we have the number of books sold. Which one is y and which one's x? Yes, very good. How do you know that? It was like that in the other one, yeah. Well, we can also use that phrase varies directly. That's actually quite helpful because if you remember that y varies directly with x. Y varies, that doesn't say varies. What did I write? Y varies directly with x. When you see that phrase, varies directly, what comes before it is the y. What comes after it is the x. Okay? Get that part down. That's important. That's going to be your key to determine what is your y variable and what is your x. Y varies directly with x. So the profit varies directly with books that sell. That's how you can tell. So our first step is to find the slope. Find m. How do we do it? Aiden.
601.65 divided by 63.
Good. We need to go back that y divided by x, which is the profit, $601.65, divided by the books that sell, 63. Okay? Which 601 0.65 divided by 63. I got $9.55. Can I have a second on that? Good. Okay. And that matters because that's our slope, right? That's our m. So in step 2, when we write the equation, y equals mx is the equation of a direct variation. We just found m, so we've got y equals 9.55x. And that's the equation that we're going to be using to answer the question, which is, how much will she earn for selling 59 books? So in this case, which is different from the last one, in this case, which variable is being given to us? If we want to answer how much will she earn for selling 59 books, which variable does that 59 books represent? X. So using this equation, y equals 9.55 times 59. That operation, that product, will give us the profit, y, which is $5,563.45. Okay? Questions on that? I'm going to have you do the next one yourself. So if you've got a question, ask now or wait till I come around and ask me then, I guess. That works too. Okay, the third one says, the distance Carl travels in a day varies directly. There's that important phrase. The distance Carl travels in a day varies directly with the number of hours he drives. If he travels 270 miles in 6 hours, how far will he travel in 15 hours going that same speed? So I'm going to pause the video here. I want you to work through each of these steps. Find m, write the equation, solve for the variable, answer the question. Raise your hand when you're finished so I can come take a look. If you get stuck along the way, I will gladly assist you. But I'm going to pause the video here so I can walk around and help you out. All right, and we are back. We found the answer to this. Ended up being 675 miles. The distance, y, varies directly with the number of hours, x. So if he travels 270 miles in 6 hours, we first took that y divided by x, that 270 divided by 6, and that gave us 45. Okay? And what that 45 represents is the number of miles driven every single hour. Okay? So we wrote our equation, which was y equals mx, but m we replaced with 45, because that's the value that we found there. So y equals 45x. We looked at the question, said how far will he travel in 15 hours? We had to decide whether that 15 was an x value or a y value. And because it's given to you in the units of hours, and the hours he drives is the x variable, we took 45 times 15. We plugged that 15 in for x, and we got 675 miles driven. Okay? Now, of course, this is assuming that he's going that 45 miles per hour the entire time. So no stoplights, no deer crossing the road, no speeding up. Okay? It's just a constant 45 mile per hour drive, which is unrealistic to maintain that speed for 15 hours, but still, there we go. Carl's a master, I guess. Okay. All right. So the second page of this, I had you go on to that. Just kind of looking at what it has in store for us here. We've got the cost of sod varies directly with the number of yards purchased. There's that phrase, varies directly. Y varies directly with X. The cost of sod varies directly with the number of yards purchased. There's our Y, there's our X. Once you determine that, you can calculate the slope, write the equation, and answer the question. Same kind of process here, okay? The next one, the amount you are charged per minute of cell phone usage varies directly with how long you use the phone. Did you know that you used to be charged per minute talking on the phone? It wasn't like an unlimited plan as most plans are now. So like when you hung up the phone and it showed you the time that you were on the call, if it was like, 59, like 3 minutes and 59 seconds, you were golden because they rounded down, which was kind of nice. Okay, so you're only charged for 3 minutes instead of 4. It was the little things in life that made us happy back in the 90s. Okay, but anyway, if your bill is $364.40 for 4,555 minutes, how much will it cost you to talk for 3,400 minutes? Okay, so again, the amount you are charged varies directly with how long you use the phone. From that, you can determine your y and your x, and you can go to town with finding the slope, writing the equation, etc. Does St. Vincent do any like heartogram sales? Do you know what I mean by heartograms? No. Well, for Valentine's Day, we would be able to like send nice notes to your classmates, and you could either send them a sucker or a pencil. And student council was always kind of in charge of it. And what made it challenging was predicting how many suckers and how many pencils to buy, right? Because you didn't want to buy too few, obviously. You also didn't want to buy 1,000 more than you needed because, well, then you're wasting money. So we set this up as kind of like a math word problem here. It says the number of heartogram suckers needed varies directly with the number of students in the school. Last year, you needed 1,017 suckers for 452 students, and this year there are 384 students in the school. Okay, this is kind of your what's my y, what's my x situation here. You can buy boxes of 300 suckers for $120 per box. If you sell each sucker for $1 and you sell exactly as many suckers as the equation of direct variation suggests, what is your profit? So this goes the next level here. We have the real life situation, and then we have the actual application of it. What can we use this information for? Okay, so to start, it's the same setup as the other 4 that we've done. You want to find your y, find your x, find the slope, set up the equation, okay? Calculate how many suckers you will need for 384 students. You can buy boxes of 300 suckers for $120 per box. So how many boxes will you need to buy? How much will it cost? If you sell each sucker for $1 and you sell exactly as many suckers as the equation of direct variation suggests, so kind of the answer to your above section there, what is your profit? How much money do you make? Right? So multi-step here. Could be a brain buster, but it's not. Okay? But it's one step for the actual application of it. And then I think it's the last one on the page. The number of gallons used to water your garden varies directly with how long the hose runs. If the hose runs for 5 minutes and 48 gallons are used, how many gallons will be used in 23 minutes, 45 seconds? This one is more similar to the previous 4. It's kind of more straightforward here. What you got to be careful of, though, is this 23 minutes, 45 seconds. Okay, I'll give you a hint. The decimal equivalent of 23 minutes, 45 seconds is not 23.45 because minutes are not out of 100. It doesn't take 100 minutes to make an hour, right? It's out of 60. So you have to kind of do some extra calculation to get that decimal equivalent for 23 minutes, 45 seconds. It is not this. Okay? So that is your homework for tomorrow, finishing up 37. 4 questions on that second page. 3 of them are pretty straightforward. The heartogram one will require some extra thought. If you get stuck, remember, I don't just want to see a blank section here and say, I didn't get it. Okay, I need to see what you tried to do. This first part, especially, just like the other ones, I would want you to at least get that far. Maybe the application part might get a little bit hairy, okay? But don't just leave it blank, because that tells me you didn't try anything, right? I want you to at least try. But the process, we've run through it several times now. That doesn't change. Final questions, comments, concerns, complaints, compliments, congratulations, or criticisms. Excellent, folks, with gusto. That's how you math.